Hey everyone, welcome to Knowing Nuclear. In this episode, we are going to be talking about how nuclear fuel can provide more energy than other energy sources. A force is a push or a pull. If something's pushing on something else or something's pulling on something else, there's a force. Pushing through some distance transfers energy. We have four fundamental forces: gravity, the strong force, the electromagnetic force, and the weak force. Those are the only fundamental forces. Everything else, like the force of a spring or friction, all of those forces actually come from these four fundamental forces. So we'll talk a little bit about how these four fundamental forces compare in terms of strength. If we look inside of a nucleus, like that one at the top right, it's got all of the forces interacting. The gravity force is going to be attractive, and it's going to be 2 decillionths of a newton. A newton is roughly the weight of an apple. So the gravitational force between the protons and the neutrons and so forth is 2 decillionths of the weight of an apple. If we compare that to the weak force, the weak nuclear forces inside the protons and the neutrons inside the nucleus, it's roughly 2 thousandths of a newton. The weak nuclear force is what makes a proton turn into a neutron and makes a neutron turn into a proton. 2 thousandths of a newton is roughly the weight of a single drop of water. That means the weak force inside all of the nuclei in our bodies and the world around us are exerting forces that are roughly the same as the weight of a drop of water. That's really pretty incredible because nuclei are so incredibly tiny, and yet that weak force is huge. Then we have the electromagnetic force. It's also happening inside of nuclei, and it's stronger than the weak force. Well, the electromagnetic force is repulsive, so it's going to try and push that nucleus apart. And it's roughly 200 newtons. That's the same as the weight of a medium-sized dog, like a Springer Spaniel. So we've got a 200 Newton force pushing apart all of the nuclei in our body. My cells are made up of molecules, molecules are made up of atoms, and every atom has a nucleus. And inside that nucleus, unless it's hydrogen, forces of roughly 200 newtons are pushing apart the protons. The neutrons are just sort of along for the ride. It's really the protons that are getting pushed apart. The strong force, as you might have guessed, is very strong. It holds a nucleus together with roughly 30,000 newtons. That's about the weight of a grand piano. So when we go from gravity, where there's practically no force whatsoever to worry about, to the weak force, to the electromagnetic force, to the strong force, we see that the strong force is really a whole lot stronger. If we can use these nuclear forces, the strong force means more energy. That's why this nuclear fuel bundle can actually provide enough electricity for a Canadian family for 200 years. In fact, if all of the power you ever used came from nuclear power plant, the solid waste that you generate from that power plant would fit inside of a soda can. Kind of incredible. So what does that mean at a provincial scale? Well, Ontario has managed to completely get rid of its coal-fired power plants, largely due to nuclear. Alberta still uses a lot of coal. Alberta actually uses more coal than any other province in Canada. If we look at the total amount of coal that Alberta uses in 1 year, if we put all of that on a train, that train would stretch from Calgary to Sudbury if you're allowed to cut through the US. So the total amount of coal used on the planet, put on a train, would actually wrap all the way around the Earth 40 times. So how much would it take to replace all of Alberta's coal? It would take 4 truckloads of uranium fuel. So when we talk about coal-fired power plants, what do we do with the waste? We let it into the atmosphere. It's gas. It gets everywhere. That's the CO2 that's emitting that is actually changing the environment that we live in. That's climate change. When we have something solid like nuclear waste, we can hold on to that and put it into a safe storage facility, which we'll talk about in another Knowing Nuclear video. The important thing, though, is this million times difference in the amount of energy stored in nuclear fuel bundles compared to the amount of energy stored in coal. So, if we were to compare how far we could drive with the same volume of different fuels, with wood, we could go like 7 meters. Coal will allow us to go about 10 meters. Crude oil would almost go twice as far at 18 meters. But the same volume of nuclear fuel that would allow you to drive 18 meters with crude oil allows you to go from Saskatoon to Vancouver. That is huge. Nuclear power has a lot more energy associated with it. In this XKCD comic strip, they suggest that for the energy density of nuclear, we have to use log scales because otherwise you just have this huge stack of paper. So nuclear brings more energy to the table for us to use. Yes, we have to make sure we're safely handling the spent nuclear fuel bundles, but those spent nuclear fuel bundles are actually easier to handle than the waste from coal, natural gas, or gasoline. This is why we only need one deep geological repository, just one hole in the ground, for decades of all of Canada's spent nuclear fuel. That's the Deep Geological Repository the Nuclear Waste Management Organization is currently looking at building in Canada. So that facility is on the way, and we just need just the one site because nuclear fuel has so much energy packed into it.